Today we'll discuss about macrostates and microstates of statistical mechanics. So the first we'll discuss about their definitions and then we'll have some examples on macrostates and microstates. So what is macrostates? As name suggests, a macrostate describes a system at a macroscopic level, which focusing on its overall observable properties. A simplest example, if you have a gas, in a macroscopic state, the properties can be defined as temperature, pressure, or its volume. So this is the concept of macrostates. Now we know this temperature, pressure, and volume, it really depends on the position and the velocity of the particles. Now the position and the velocity of the particles will be defined by the microstates. So what is microstates? A microstate is a specific arrangement or the configuration of individual particles in a system, taking into account the exact position and momenta of each particle. One system has only one microstate at a time. So you can think about the constituting particles, their position and velocity defining its microstates. And when you have a microstates, the combination of microstates gives you the concept of macrostates. Now, a simple example I have taken. So here we have two boxes and we have four particles. We'll go to arrange those things. Now we can see box number 1, we have 4 particles, and box number 2, the particle is 0. So we have a combination of 4 and 0. This is one type of microstate. Now another possibilities are there. There may be 3 and 1. In first cell we have, in first box we have 3 particles, in second box we have 1 particle. So there are 4 possibilities are there. Okay. So 3 and 1 combination is possible. In one box 3, another box this is 1. So how many microstates are there? How many arrangements are possible? There are 4 possibilities are there. Then comes the next combination. We have 2 particles in each boxes. So the how many possibilities are there? So obviously there are 6 possibilities. We have 4 different colors, so arranging in a proper way. So we'll have 6 possibilities, which will be considered as microstates. Now another combination is possible. In box number 1, you have 1 particle, and box number 2, there are 3 particles. So 1 and 3 combinations. How many possibilities? This will be 4. And the another one is 0 and 4. In the second box, you have all the 4, and the first box is 0. So 0 and 4. How many microstates are there? How many combinations are possible? This is 1. Now in the statistical mechanics world, this is known as the most probable macrostates. Is the one with which the maximum number of microstates are there. So when you have a maximum number of microstates, so this is the most probable or the most favorable macrostates of the whole system. Now we can take this particular example where we have 6 microstates in one combination. So this is the most probable macrostate or the most possible macrostates of this particular system. Now we have already discussed about the macroscopic properties. So macroscopic properties can also be defined as the thermodynamical properties. Obviously the other properties can also be considered in that way. Material properties we are talking about. So in a simple way, one can say a macrostate described by the properties such as pressure, temperature, volume, internal energy, enthalpy, etc. A microstate is described by quantifying the variables associated with the states of the individual atoms or molecules in a system. So when you talk about individual atoms, individual particles, then this is the case of microstate. So this state will be defined as microstates. But when you have a combination of microstates, this will be defined as the macrostate, which will define the macroscopic properties such pressure, temperature, volume, etc. Now we know in statistical mechanics there are 3 types of statistics. One is known as Maxwell-Boltzmann, another is Bose-Einstein, and we have the Fermi-Dirac statistics. So we are just try to show the macrostates and microstates of these 3 different statistics with a simple example. So here we have taken 2 particles and there are 3 states available. So obviously you can think about 2 bolt zones and 3 cells are available. Now we can think about 2 bosons, 3 states are available, and we can think about 2 fermions and having 3 states are there. We're going to arrange them in different states. So first we're going to calculate how the arrangement are possible. So for the Maxwell-Boltzmann, the arrangement is simply g to the power n. So this is 3 to the power 2. So this becomes 9. So there are 9 possibilities for Maxwell-Boltzmann statistics. For the Bose-Einstein statistics, if you put the values over there, n and g values over there, you will get, for the Bose-Einstein statistic, this is 6 possibilities. If you have 2 particles and 3 cells are there. And for the Fermi-Dirac statistics, there will be 3 combinations. If you just plug the values over there, you will get 3 over there. Now we'll see how we are arranging this one. Now see, you have cell or state 1, 2 and 3, all the there. And we have 2 particles. As we know, the bolt zones are classical particles. They are distinguishable particles. So we can take 2 values, 2 symbols for this. One taken as A, another was taken as B. So how we can arrange this one? So the possibilities are, so here we can take 2 particles and others may be vacant. Okay. So the macrostate is given as, so microstate combination is here, and the macrostate is given as 2, 0, 0. Same way we can have 0, AB and 0 and 0, 0, AB. So there are 3 possibilities of this microstates, and the macrostate is given as 2, 0, 0. So there are 3 combinations of this. Now we have another possibilities. We can put 2 particles in 2 cells and 1 will be vacant. So how many combinations are possible? You can see there are 6 combinations are possible. This is given as 1, 1, 0. Now, so this is the, so if you add all those things, so there are 6 microstates of this combination and 3 microstates of this combination. And macrostate is given by this one, 3 and 6. Now coming to the case of bosons. So again, we are following the Bose-Einstein statistics. You have 2 particles, 2 boson particles are there, and we're going to arrange in 3 different states. Okay. So how we can arrange? We can put 2 particles in one cell, AA, and others may be 0. So how many possibilities are there? Obviously, there will be 3 possibilities, 2, 0, 0. And the other possibilities are there, 2 different cells, there will be 2 particles and 1 will be empty. So this is AA0, A0A, and 0AA. So another 3 combinations are possible, or another 3 microstate combinations are possible over there. So there are 3 microstates of 2, 0, 0 and another 3 microstates of 1, 1, 0 for the bosons. Same example will be taken as for the Fermi-Dirac statistics, where we have 2 particles. Okay, they are indistinguishable. Obviously, boson and fermion both are quantum statistics, so the particles are indistinguishable and they will be represented by same notation A and A. But for the fermion, they must follow the Pauli's exclusion principle. The wave function must be disymmetric in nature. So in one state, so there will be 1 particle only. So 2 or more than 1 particle is not accepted in these cases. So how many possibilities are there? Obviously, we can take AA0, A0A and 0AA. So only these possibilities are there. So AA cannot be in same state. So how many microstates are there? 3 microstates. And obviously macrostates combinations are given as 1, 1, 0. So today we'll discuss about the concept of macrostates and microstates. In simple way, the macrostates is a possible arrangement of constituting particles. And the combination of these microstates is given as the macrostate, which is basically defining the properties of the material or property of the system. Thank you.